Everybody. Good evening, everybody. I have the pleasure this evening of introducing Gombin Kiani of the University alumni with a BSc in Civil Engineering and an MSc in Mechanical Engineering. And he's a seasoned change maker impacting industrial corporations and startups. He has a proven track record in technical and value engineering and holds a fellowship in engineering and an MBA. So a very qualified gentleman. He is the founder of the Users Group, Engineering and Technical Subject Matter Experts of Alberta. And currently he holds the position of Vice Chairman of Standards Council Canada. He has done peer reviews.
From the roof of the embassy amidst chaotic scenes. The world
somebody mute.
Defeated and humiliated. But at least 30 years of war against the Japanese, against the French, against the Americans, and the world.
I'm sorry, I'm getting some background noise there.
You'll have to unmute. I muted everybody, including Gobind.
Okay, I'm not sure where that background noise was, but I'll continue from roughly where I'd finished here. So Gobind, he's done peer reviews on emissions management regulatory documents for Environment and Climate Change Canada and participated in research and development initiatives for emissions management and reduction programs Alberta, as well as Canada Oil Sands Innovation Alliance, a world-leading innovation alliance that set the model for sharing intellectual property to accelerate environmental performance. Gobind draws upon a unique mix of public safety policy and startup venture capital experience. He has over 24 years of energy sector experience, including regulatory, standards, technical compliance, strategy governance, digital innovation, engineering management, technology, sustainable development, and operations. He's also skilled in asset integrity and maintenance management. Gobind is involved in technical standards, energy, technical, public safety, and has been a mentor judge at the First Robotics Western Canada competitions. He is also the past chair of Calgary Branch Executive Committee of APEGA, and he's been a long-standing member of our group, the Canadian Prairies group of chartered engineers. So with that, if you'd all join me in welcoming Gobind, and Gobind, I'll hand over to you.
Gobind, you need to unmute.
Thank you, Hugh. Thanks, Nigel. Good evening, everyone. As we are all going through this new digital world of sharing knowledge with each other, I would like to present today the emissions management. I do want to bring it to all of you on a quick note that emissions is a vast subject. I'll try my best to cover as much as I have the knowledge of and have you all understand what I'm going to share today. So I would like to first take the opportunity to acknowledge the traditional territories of people of the Treaty 7 region in Southern Alberta, the city of Calgary, which is home to Métis Nation of Alberta Region 3. So with that acknowledgement, I would like to just quickly read my disclaimer of this presentation. The content of this presentation are intended for educational purpose only and do not replace independent professional judgment. They do not constitute advice and should not be relied upon in making or refrain from making any decision. Statement of fact and opinions expressed are those of speaker, which is myself alone, and are not the opinion or position of my employer, past or present, nor those of professional bodies and committees I participate. So with this disclaimer, I do want to say that I participate in API as an active member of committee for last 15 years, ASME for last 10 years, CSA, which is Canadian Standard Authority, close to about 7 years, and ISO or Standard Council of Canada for almost 11 years. And I do not want to replicate any of the discussion we do in code committees over here today. Here's the quick outline of my presentation. I'm first going to talk about history of emissions. I'll give you a little bit about what is Clean Air Act. Then I'll talk about fugitive emission standards. I'll also talk about net zero emissions, followed by codes and regulations in today's industry on emissions. And then what are the ramifications of non-compliance? I'll tell you a little bit about that as well. What happens as a ramification down the border in the United States and what happens in Canada. Cost of failure, I'll talk about that, and then we'll open the floor for question and answers. I don't know how many of you know, as a history of emissions, the Sudbury, Ontario acid rain. Sudbury, Ontario has been famous for metal mining and smelting since 1900th century. And in early 60s, the smelters emissions peaked. And the emissions were the largest source of sulfur dioxide. Since then, thousands of tons of metals particulates emitted from smelter over years, as quoted by Potvin and Negusanti in 1995. So acid deposition, transformation of sulfur dioxide and nitrogen oxide pollutants, such as sulfuric acid, H2SO4, or NH4NO3, NHNO. These were converted into acid when contacted in water. You see the picture on the right is the courtesy of Laurentian University, Sudbury, Ontario. When the acid rain falls, you can see the tree that's completely destroyed. Even some rock on the left was destroyed. Let's look at some more. So we all know beautiful county or state of California. In 1948, they announced emergency. It was a smog. They called it as Donor smog. The reason was Donor Zinc Works was the company who was emitting emissions in the atmosphere. And that's how this term came out as 1948 Donor smog. The major federal clean air law became a legacy of this environment disaster that focused the national attention in the United States on air pollution. In late October of 1948, a heavy fog blanketed the Valley of California. That days passed, the fog became thick, acrid smog that left about 20 people dead and thousands ill. Not until October 31st, that Donor Zinc Work shut down its furnaces, just hours before rain finally dispersed the smog. So they realized the source of the smog was. What was the reason? And as you see the picture on the left with the smog that was during daylight, and on the right was the plaque, which I read it to all of you. So do we believe all that the air is always green near plants? No, I'm just trying to make a good humor here. Air is never green near the plants, but we can make it green by managing proper emissions. So a little bit more about the history. Renewal of Canada and US Climate Agreement and International Joint Commission. That was one of the agreement done between Canada and United States. Air quality objectives and specifics. There was another document written between United States and Canada. Assessment, notification, and mitigation purposes were documented. Scientific and technical activities and economic research was done between two countries, or is still being done. A lot of exchange of information has been done regularly. There is an air quality committee between US and Canada that regularly meets and discusses the quality of air. And they also discuss quality of air or the effects of air when we see some man-made / natural disasters such as wildfires. Responsibilities of International Joint Commission, and that is being discussed as well. Review and assessment, consultations, settlement of disputes, implementation of codes, regulations, existing rights and obligations, amendments, terminations, or any entry into force also is part of the emission management. Let's look at a little bit on the second point, which was the Clean Air Act. How did all this materialized? See, the Act of 1963, we call it as the Clean Air Act, was developed or authorized development of national program to address air pollution. This act got expanded in 1967, which became an enforcement procedure and expanded its scope. And what was it? We'll keep discussing that. In 1970, they increased standards and enforcement authority. In 1977, they did amendments and further refined the clean air requirements. And in 1990, the document, which looks as today, is 189 toxic pollutants were requested to be phased out of ozone depleting chemicals. An increased enforced authority was put in place. So this is all transpired in many, many years. What we all hear today in our oil patch or energy industry, emissions is very important. This has been talked since 1963. So before United States Environmental Protection Agency, which is EPA, or Canadian Clean Air Act, or US National Ambient Air Quality Standards were written, in early 1958, the Health, Education, and Welfare Department in US did a survey of the Los Angeles refinery, which was conducted by Dr. Bernie Stigwood. And he came with a conclusion that components in facilities leak. Now, this particular, of course, survey was done on a refinery, but components in a facility leak means components in a food processing, in a pharmaceutical, in a chemical plant, in a petrochemical plant, or any facility would leak. Even in your house, in the boiler mechanical room, you have components. If they leak, they cause emission. Many components have potential to leak, which is a boiler in the house, for example. Equipment leak causes pollution problems, and that causes emissions, and those rates can be calculated. And how they are calculated, we'll talk in the next slides. But all this is possible. So fugitive emission standards, how did it all start? So in 1990, the United States Environment Pollution Agency enforced the Clean Air Act. And the enforcement started on chemical and petrochemical or petroleum industry, who started to see effects. They limited the emissions of hazardous air pollutants to 500 ppm by volume in chemical industry. And the petroleum industry limit was 10,000 ppm by volume. Around 1989, engineering managers of Clark Reliance joined the Instrument Society of America, and they established a working committee on fugitive emissions. Now, emissions could be few different types, but fugitive emissions are the most prominent emissions, which could cause hazardous to health, to air, to quality of air, and that's what is important. So that's why the established working committee was formed in fugitive emissions in API about 12 years ago. And similarly, ISA was formed in 1989. Valve companies and sealing product companies were asked to review leaks and emissions in their facilities, upgraders, plants, refineries. This has nothing to do with only valve companies, even pump companies, compressor companies, pressure vessel companies, any companies who had produced a product which is going to be used in industrial revolution was requested to look at the possibility of leaks. So in motor industry, car companies were asked to look into as well. From 1968 to 1998, there were a lot of things changed in the industry. I'm again bringing a little bit of history here, but this history relates to how the emissions were analyzed. So we all know that elimination of asbestos as packing material was stopped due to numerous lawsuits about that asbestos is hazardous to health. Similarly, Clean Air Act and enforcement policy of United States, EPA, came in effect. In Canada and United States signed the air quality agreement, and that was signed by our premier, our Prime Minister, Martin Bryan Mulroney, in 1991. That was signed to address transboundary air pollution leading to acid rain. Both countries agreed to reduce emissions of sulfur dioxide and nitrogen oxide and to work together on acid rain related scientific and technical cooperation. And in year 2012, our current Prime Minister renewed this agreement for another 25 years. Not only this agreement, but Paris Accord and other agreements were signed along with these. So in the industrial world, people say, asbestos, wow, who moved my cheese? That is, who moved my asbestos? Why? Asbestos was a great product. It had a unique fibrous characteristics. It had little degradation at high temperatures. It was made from stronger when it was added with Inconel wires. And tiny fibers were easy to form as in form of a mesh without binders. So it was a best sealing product. And that's why I kind of called it as who moved my cheese. But some cheeses can be hazardous to health. That's why we need to look at which ones are good. So let's look at a little more about Climate and Clean Air Coalition to reduce short-lived climate pollutants. What were those pollutants which were causing Clean Air Act and other acts coming out about emissions? Black carbon is one, methane is another one, hydrofluorocarbons, tropospheric ozone. So I've just listed the key four. There are, as I said earlier, over 188, 198 different short-lived climate pollutants are available. Why reduce short-lived climate pollutants? Climate benefits, health benefits, food security benefits, economic benefits, and sustainable development goals. Now, you all must be thinking what kind of food security benefits you will gain. Well, I talked a little while ago about wildfires. If you imagine the wildfires happen in down south or they happen out west, but our atmosphere gets foggy and people can't breathe properly, they get asthma. You can imagine what happens to the crops in our cities, in our neighboring areas. The crops get damaged as well, or they absorb that smog. And then finally, when the crop gets converted into food, we are eating that. And that means we are taking those pollutants into our body now. So certainly food security is one of the key components of controlling emissions. Let's look at a little bit about net zero emissions. So everybody knows, I'm sure, that the United Nations in 2015 under Paris Agreement, legally binding international treaty was signed on climate change, which was adopted by 196 parties at COP21 in Paris on December 12th, 2015, and was effective from 4th November 2016. And what was the purpose of all this agreement and what was the goal? Goal was to limit global warming to below 2 degrees, preferably 1.5 degrees Celsius, compared to pre-industrial levels. And countries should aim to reach global peaking of greenhouse gas emissions as soon as possible to achieve a climate neutral world by mid-century, which was a landmark in the multilateral climate change process. So you guys might have a question, what was COP26? Well, I would say there's a lot of information available on Google on COP26, but let's look a little bit more here about net zero emission. So this chart, I don't know how many of you have seen this chart. It's been floating on social media a lot in LinkedIn or many other websites such as International Energy Agency. This is courtesy from them. They have this chart published. So what they're looking for is, we are here in 2021, where we are seeing that they're saying no new unabated coal plants approved for development. So starting now, there will be no more coal plants which will be approved. And then by 2025, they want to stop no new sales of fossil fuel boilers. There is boilers which run with oil or any other means of fossil fuel. By 2030, industry is looking at universal energy access. All new buildings are zero carbon ready. 60% of global car sales are electric. Most new clean technology in heavy industry demonstrated at scale, and 1,020 gigawatt annual solar and wind additions. Phase out of unabated coal in advanced economies. So by 2030, everybody wants to, or target is to phase out your coal if possible. By 2035, most appliances and cooling systems sold are best in class, so they should be zero emission. 50% of heavy truck sales are electric. No new ICE car sales, which is the industry standard combustion engine. All industrial electric motor sales are best in class. Overall net zero emission electricity in advanced economies. So that's by 2035. By 2040, we want to see 50% of buildings retrofitted to zero carbon. 50% of fuel used in aviations are low emission. 90% of existing capacity in heavy industry reach to end of investment cycle and net zero emission electricity globally, and phase out of all coal and oil power plants. And in 2045, 50% of heated demand is met by heat pumps. And by 2050, more than 85% of buildings are zero carbon, 90% of industrial production is low emission, and 70% of electricity is generated globally from solar panels or wind or alternative energy. And all these are projections, of course. Let's see how we head into 2050, but we should take every 5 years and see how much industry has progressed. So that's the chart which I read it to you to make it very clear. Let's look at a little bit about practices, codes, and regulations. So there are state and provincial regulations. A lot of that started in West. I always say wind blows from west to east. So I'm saying that everything starts here and then it drifts to eastwards. I'm joking. A lot of codes have been written or regulations have been written in Alberta, like Directive 60, Directive 17, similarly get adopted by the BC Oil and Gas or Saskatchewan. California have their own codes and regulations. Some of them are called as South Coast Air and Bay Area Air Quality Management. Climate and Clean Air Coalition, Canada has written their own best recommended practices. We can call it best available control technology. Limiting leakage rates from 1000 ppm to 500 ppm to 100 ppm. That's what industry is going for. We hope industry can make it there. So what more is available in industry? There are leak detection and repair methodologies are available, which are basically federal and state-driven regulations. Emission leak prevention or ELP, which are driven by consent decree. Consent decree in United States is a terminology used to fine companies. Same thing is considered to be used in Canada as well, consent decree. leak definitions less than agreed or regulatory requirements for 5 years. So anything which leaks, if you fixed it, must last for 5 years. That's what is expected in some hazardous areas like management of benzene or management of sulfuric acid and certain components which are toxic to air pollution. Those components have certainly mandatory requirements for 5 years going forward. I haven't seen many manufacturers meeting that requirement yet, but it's beginning to come through and a lot of them are starting to accept it. Industry codes, API 622, which is American Petroleum Institute, 622 is a number. API 624 is another number. API 641, these are all the industry standards for low emission products. ISO, on the other end, in Europe, came up with their own numbers and own codes called ISO 15848, part 1 and 2. And TLUFT, which is one of the third-party company out of Germany. They're more into quality control. In Europe, especially in Germany, they came up with technical instruction on air quality control. If you type TLUFT, technical instruction on air quality control in Google, you'll find a large document as a PDF, which is free to download, and you can read that as a bedside reading for a lot of knowledge which European countries are adopting and working towards reducing emissions. So what are the ramifications of non-compliance? I mentioned it to you earlier a little bit, called consent decree. That is number 1. Civil penalties. OSHA 1910 process safety has adopted all these. US Air Canada Quality Agreement also talks about this. This agreement, as I talked earlier, in 1991, an agreement to address transboundary air pollution. Pollutants released at one location can travel long distance. Agreement which has led to reduction in acid rain in 1990. All this is expanded in 2000 to reduce transboundary smog emissions under the ozone annex. And all this brings nothing but fines and criminal prosecution. Now let's talk a little bit about fines. So this is the data available on the internet, but I thought of sharing this with you. Environmental Integrity Projects is the company who has published this on their website. However, they've published very low numbers, but if you just Google the first one, Noble Energy fine, 3 years ago, Noble Energy was fined. It says here's estimated cleanup cost 60 million, but it turned out to be that was close to 96 million. The date of settlement of notice to them was April 22nd, 2015, but they finally settled the payment of over $96 million as a civil penalty, not $4.95 million as you read here. That could be reciprocated on an annualized basis, but when you Google Noble Energy Environmental Cleanup EPA enforcement fine, you will see the numbers. Similarly, PDC, Slauson, Devon, Chesapeake, Gulfport, all these companies were fined in respective years, as you see here listed. And this is a correct data available from Environment Integrity Projects in USA. So we all talk about cost of failure. We all know what is the visible loss versus hidden loss or hidden cost. Hidden cost could be cost of maintenance, repair, operation, downtime, material, environmental, cleanup, loss of public image, personal injury claims, environmental fines. So there's a huge hidden cost. Whereas visible cost is what? Just the leaks. And what comes with the leaks? Loss or profit, both go along with the leaks. So with this, I would like to share one quick video showing you emissions before I conclude my presentation. So I'm just going to minimize this screen and go back and turn on my video. And this particular video I would like to share because I would like you to understand that it's not just the emissions, but It's the bad effects of emissions. So let me just pause this video. And now I'm going to somebody has turned on the speaker, but that's okay. So here's the latest video of emissions. Everyone can see that, I hope. I'm going to play that. So this is the emission coming out of this joint, if you all can see. Now this was monitored and controlled by use of optical gas imaging methodology, which is called as OGI. Otherwise, these emissions are not visible at all, but you can all see that the emissions are continuously coming out of this. Let me play it once more. You all can see now the video, and you can easily see the emissions coming out of this particular equipment. And you can imagine that when you have emissions coming out of your toxic compounds flowing in your system, that could be very dangerous. So I'm going back to my presentation here. And so I have put a last picture here, which also opens up the floor with questions and answers. I'm calling this as the ultimate in leakage containment. So you really don't want this situation happening where you have to keep a pot, you receive the leakage or the drip coming from this valve. You should rather have this containment, not have this containment and have emissions controlled. So Nigel and Hugh, I'm opening up the floor for question and answers.
Yeah, thanks very much, Gobind. Does anybody have any questions? Maybe shout out if you do. So we have somebody who's not on mute, who's got a noise going on in the background. It would be helpful if you're not talking to mute, please. Okay. Well, Gobind, I'm going to ask a question since I don't hear anybody there. So all these emissions, you're saying that industry in general is trying to cut down the fugitive emissions in particular, but what about things coming out of smokestacks? Is there much being done to try and stop the emissions out of petrochemical plants and smokestacks flaring and things like that?
Yes, so for example, CSA came out with a code called B149.3, which is a burner management system. So burner management system is the basic requirement, and it is mandatory to have replace all your smokestacks with minimum burner management system by 2025. So conventional systems have to be replaced so that the emissions going through the flare stacks get reduced and stopped at the burner management system itself. So yes, that's certainly a fugitive emission, and that emission is being addressed. Yeah. So in Alberta, we look at Directive 60, which talks about flare stacks emissions monitoring.
Okay, thanks, Gobind. I see one in the chat there from Richard. How confident are you in that reduction of emissions going forwards to 2050?
So, Richard, your question of confidence is only towards me, and I'm quite confident the technology now has improved a lot. So I'll give you an example. What you saw the video, which was a movie taken by optical gas imaging camera. Now that particular was done for only 3 minutes. And if we put that camera on a constant basis on an equipment, then it becomes very expensive. But if we put a camera on a plant, or say 10 cameras in a plant covering the whole plant, then if we calculate the amount of emissions emitted by that particular plant, then we are able to understand exactly the cost of loss going through due to that emission leak happening, which is not visible. And when you take that and equate those dollars back to the management, it is easy to convince your management that they should consider implementing the reduction of emissions faster. And current artificial intelligence has helped the smart OGIs to come out and monitor emissions, not only while production, but while there is no production or low production. So at the maximum, how much they can go, at the minimum or at the moderate, how much they will emit. And those numbers are very accurate, plus minus 3%. And then when you take those numbers, that's where all the personnel within your management would open the eyes and say, oh, wow, we can do this much saving. So they start considering to go with the technology available in the industry for improving emissions or reduction of emissions. I gave the example of the flare stack in the previous question raised by Nigel. And that was a very good example to say that this is one of the good example to consider, that industry has been given timeline till 2025 to change all their conventional boilers, burner management systems to be advanced level with a variable frequency drives or AI operated. And that will all change, but it takes time for industry to adopt. And by 2050, I'm quite confident, even if we could go forward and reduce the emissions by 60%, 65% than what is expected, that will be a huge achievement. Thank you.
Great. So there's a couple more in chat there, Gobind, from Alan Murray. Have punitive fines been shown to work? The cost of remediation may be much higher than the fine. And then which federal government department is involved in the international control bodies for the environment and so on?
So first question, punitive fines have been shown to work. Yes, it is showing to work. So I'll give you an example. For example, in Alberta, the fine was capped to $10,000 at one time. And now that has been changed to fine depending upon the spillage. Similarly, if you have heard recently, last week, our premier implemented that any companies who are abandoning wells, they will be forced to pay the fine to remediate and bring the soil or ground back to how originally it was. And they will be fully responsible for that. So that's another way of implementing the fines, showing them that the fines would be huge if you start spilling. I was talking to, as a matter of fact, Alan, last week, one of the old school gentlemen out in north from here, and he said to me, there were days when we had to do some, pressure reduction. We just connected the hose in the pipeline and brushed some trees. I don't think that's any more acceptable. So
not acceptable, but it's still done though, Govind. That's the thing. So, I mean, if you know very well what happens, these fellows look around and there's no one around that looks official. They just vent.
Correct. Correct. But that's more and more to do with the training, and industry has been securing the way they have secured safety parameters of training their staff, their operators. The training is important, and training of emissions on their particular area of a plant is very, very important. And that will certainly reduce. So the federal government fines have grown substantially, to answer your question, and the cost of remediation has been reduced dramatically. So for example, an OGA camera, optical gas imaging camera in the year 2005, when it brand new came out, was about $50,000. Today, that camera is only about $3,000. So the cost of equipment to manage emissions is reducing drastically. And industries are certainly welcoming that and adopting more and more. So second question of yours was?
The second question was to do with which federal government department is involved in the international control.
Right.
And then there's another one, who would manage air quality in air sheds such as in the Fraser Valley that cross the Canada-US border?
Correct.
Right.
So
there's another question by Rick after that, but we'll get to that when you've done this one.
Absolutely. So, Alan, there is a Environment and Climate Change Canada has a code of practice on emissions, and that is available for free to download. It's about 800 pages. It addresses first 500 pages on automobile. And when Environment and Climate Change Canada approached me, at that time, the emissions were only 8 pages. So I kind of gave them a lot of changes. And with other colleagues in the industry, we increased those to 90 pages. And we were actually looking at getting that beyond 200 pages. But the deadline was too close, and we are now working towards renewal. So just to give you an advantage of what is available federally, then internally within provinces, each province is supposed to mandate their own regulations. So for example, I kept on saying earlier also, Alberta has Directive 60 and Directive 17, followed by individual areas. For example, Peace River County has their own directive, which goes above and beyond Directive 60 and Directive 17 of Alberta. And if you want to put a facility, or if you want to put up with emissions with an existing facility in Peace River County, you better comply with that. Otherwise, the county has huge fines. And they've already started implementing. You must have heard one of the large end users decided to quit Peace River County. This was 3 years ago because of the fines. And they realized that they couldn't manage that. That's why they started de-investing from that region. And other companies have started joining because they feel they can manage better. So the industry shift will continue because of certain nature of demands and requirements of these fines and training requirements. Furthermore, awareness is important. As the awareness grows, you will, if there is a facility behind your house, you will ask the right questions rather than you show you show ignorance. So that's what is the key. Awareness will bring people understand and make them together and follow the rules and regulations of the industry. So I hope that answered your question, that this is how it gets divided. In Alberta, there is a website which actually allows individual user company to insert their data of emissions on weekly basis or monthly basis and do an honorary system of, it's currently an honorary system of declaring your emissions. However, Methane Emission Legislative Alliance, MELA, or Environment and Climate Change Canada is now implementing further by hiring inspectors and giving them those gadgets such as optical gas imaging devices and some laser devices where they can just come park outside your facility and just run a laser gun and check the emissions. And then if they're not satisfied, they are beginning to give them authority to keep the challan on your door. They don't even have to walk into your office. They can leave it on the gate, the challan, like how you get stopped by a traffic officer, traffic police. If you're driving a little higher than expected by the traffic police, they give you a fine. Same thing is getting implemented. So more and more restrictions are coming through as the industry and the technology is evolving.
Thanks, Gobind. The next question here is, how realistic is a 70% solar wind electrical generation by 2050? Right now in Alberta, wind is currently out 821 megawatts out of a total capacity of nearly 2,300 megawatts, so about a quarter. On a dark, still midwinter night, it's going to get really a bit cold if we can't up the wind, solar, electrical generation. So how do you think it is realistic that we get so much from wind and solar?
So very good question, Rick. I do want to tell you that the chart I shared with you is an IEA chart for the global emission reduction. And we all know that we need minimum heating natural gas for heating our homes. And that's not going away, at least in our day and life. But you may see variable frequency drives, high efficiency furnaces, and better products to manage your home heating. You may also see certain new designs. For example, I've heard that I haven't seen myself. I've seen a YouTube video that in New York, people live in the house where they can convert the bed into a table or convert a certain furniture. All of a sudden they can, make it look like it's a big house, but it's really a very small, compact, livable cube. And those things are getting more and more acceptable, implemented. Certainly the taxes will be higher if you want to enjoy your luxury and benefit. So carbon tax will keep on growing, escalating. And yeah, this is how we will all adopt towards improving. The Alberta numbers, what you have put in there, are certainly great, but I do not have an answer or towards the projection by 2050 as to Alberta where that will reach as on now. I do want to bring one more question here, Nigel, which I did not address. It was from Dr. Allen. Who would manage the air quality in air sheds, such as the Fraser Valley that crosses the Canada-US border? So as we talked about, that Alberta as a province has their own directive. BC Oil and Gas has their own directive, and they should be managing their own, emissions. However, certain natural calamities, such as wildfires, are currently not in that air quality agenda, but they are being discussed. They should be in there by next year. That's what I've been told.
Okay, sounds good. Now we have a question from Hugh. Do we monitor or measure the emissions from wildfires? Should the timber industry be held responsible for fires where they have rights to log and responsibilities to replant?
Yes, Hugh, that's correct. That's what is being challenged and discussed. As in the beginning, I said, emissions are from every industry, which is what I was driving that way. It's a pharmaceutical, any industrial revolution brings emissions, so as timber industry. And currently timber industries are being very relaxed, but they are all under the Environment and Climate Change Canada new document being discussed. Are they being implemented? Not yet, but they will be forced to follow and start implementing in coming years.
Yeah, sounds good. Are there any other questions? Because we're sort of running out of time and we don't want to keep Gobind longer than. Okay, Alan says, I'm Gobind, I'm speaking of power plants located in Washington. Where did that go? Emitting into the Fraser Valley.
Oh, excellent. Yeah. So the Canada-US transboundary emissions, federally, they are managed by Clean Air Committee. So if you Google Clean Air Committee, you will find that they monitor and take the records of emissions which are shared as a transboundary emissions. And they basically trade off those emissions in terms of either giving some credits or taking some credits. So I hope that answers your question, Alan.
Yeah, I think that's good. Any other questions for Gobind? Okay, hearing none, Gobind, I'd like to thank you very much for a very interesting presentation. I think we're all very aware, given the summer, of toxins coming through the atmosphere of pollution. I think the wildfires made it very clear, but if you go down to Hamilton and the wind's in the wrong direction, you certainly know about the steelworks down there. If you're on the wrong side of the dump, you sure, I mean, and that's another one, is the city of Calgary. Can we sue the city of Calgary for stinking us out if the wind blows in the wrong direction from the dump? So I think we all know that there's a lot of pollution and a lot of things that need to be done about it. And I'm glad that slowly but surely things are happening, and we certainly appreciate you drawing our attention to it, and hope that you will continue your good work in trying to reduce emissions in the future so that we can all have a healthy life. Thank you very much.
Thank you, Nigel.
So I'm going to stop recording and wish everybody